So in this presentation we're going to be going over the low-cost start emitter controller architecture proposed solution. These are our contents. In a high level we're going to go over the problem, the solution, the general architecture. After that we're going to get into more technical details about the architecture, the hardware, software, and at the end we'll have a demo and more info. So the problem. The problem is that the Range Management Office, RMO, has to physically drive out to the range in order to control and configure specific assets. This drive is roughly 1.5 hours each way. If configurations are expected to change on a given day, a member must remain on the range in order to change a configuration to the needs of training. As the number of assets scale, so too will the time required to configure these assets, because each one must be done at the physical location of the asset. Our solution. We develop a low-cost capability to securely and remotely configure these assets on the fly. We can achieve this using a combination of satellite internet, like Starlink, or cellular internet, so SIM cards and cellular hotspots, and encrypted radio communications. Beneficial side effect of this is that if Meshtastic is the software used on the radios, the radio communications network can also be used to extend ATAC terminals. So the general architecture involved. In this we have one master node that is attached to Starlink and communicate with all the other nodes over RF. With this we have repeater nodes, which are going to be low-cost nodes that all they do is continue to transmit the initial signal from the master node to the other nodes. And then you'll have emitter nodes, which are attached to your low-cost thread emitters or other devices in order to control them. Getting more into the detailed aspect. So each master node will be hooked up with an external connection, like Starlink cellular hotspot or some other type of connection, and it will have a Raspberry Pi or any other single board computer to run the control GUI, as well as the backend to communicate with Meshtastic. It will also need that Meshtastic RF device and a power source. The emitter node will have a Raspberry Pi or any other single board computer in order to receive signals from the master node and send messages and replies back. It'll have a Meshtastic device in order to actually facilitate the RF communications. It'll need to be connected to the device controlled, whether it's hooked up directly or using a network on board to connect, and a power source to power these devices. The repeater nodes will just need a Meshtastic device and a portable solar panel battery pack. We've designed one to actually fit within the solar housing, so you can just drop them out on site in order to extend a given network. The hardware involved, so the external connection we're looking at right now is going to be Starlink or cellular hotspot. Anything is good to go as long as it allows us to route to that GUI through IP or any other type of connection. The master node single board computer must be capable of compiling and running Node.js in order to provide the GUI, running Python in order to provide the backend Flask software as well as the communication to the Meshtastic node, have a USB port for connecting with the Meshtastic node, and then can communicate to the external connection either via Wi-Fi or Ethernet port. The Meshtastic device is going to use LoRa to communicate. In the US it's going to work on the 915 MHz ISM band, and it's going to connect to our single board computers via USB. The emitter node must be capable of running Python in order to connect to the Meshtastic API, as well as to connect to the emitter or whatever other device it's hooked up to, and it must have a USB port in order to connect to the Meshtastic device. The software. Meshtastic is an open source software which is going to enable communication via a mesh network using radio frequencies. By default, it enables encryption using a 256-bit encryption key, and nodes that are not connected to the channel will still continue to transmit but will not be able to decrypt a communication if they're not on the channel with the correct key. The web GUI is a custom-written React software. It uses MUI for styling, and it uses Plotly in order to provide an interactive map of knowing where your nodes are at all times. The backend is custom-written in Flask, which is a Python framework for web interfaces. Specifically, this will be a backend type. And it will connect to the Meshtastic via Python API and USB port. And the custom Meshtastic messaging and command execution is a plugin written on top of the Meshtastic Python API using JSON to communicate over the standard Meshtastic text communication. And with this you can execute a variety of commands, and it can easily be extended and customized. Demos and more info here. Links will be provided in the description.